Hi everyone, this is the 4.1 Part 2 Ready, Set, Go notes. So we watched one video and did some practice, now we're going to do Part 2 of it. So for the Get Ready, we're going to talk all about solving equations, which again, we've already done. So this should be a nice quick review in the beginning here, and then it's going to be looking at some of the more advanced problems because we haven't done any quite like this. So an equation is a mathematical sentence that always has an equal sign. So we talked about expressions, they don't have equal signs, equations do. When we're solving equations, we want to get the variable isolated. We can do this by moving all the other numbers that are near the variable using inverse operations. So remember, inverse operations undo each other. Whatever's happening, you want to do the opposite so that it goes away. So when we look at number 1, there's actually a couple of different options we could do with solving number 1. To get rid of those parentheses, we could distribute the 6 inside. So we would take the 6 and we would multiply it inside. Now, when I look at this, however, since there's just a number over here, and I can actually divide it by 6, that's actually what I'm going to do. So let me talk a little bit more about that. So we have 6, and then x plus 2 equals 24. We know that we can distribute this inside because we're saying 6 times this stuff. Well, that means if I could just divide by 6 on both sides, that would make it go away and I wouldn't have to distribute. Since this is just a number, I can do that. I want to be careful because I can't always do it. Like, for example, if you look at number 6, it gets a lot more complicated because there's multiple pieces on the right side. But in number 1, I can do that because there's just a single number here and I'm good. So that's the first thing I'm actually going to do then, is I'm going to divide both sides by 6. When I do that, these cancel and I'm left with just x plus 2, and now the parentheses are gone. And I get equals 24 divided by 6 is 4. And now when I look at it, all that's happening is the x has a plus 2, so in order to get that x alone, the inverse of addition is subtraction. So I'm going to subtract 2 from both sides. These will then cancel, and I get x equals 4 minus 2, which is 2. Now, if I decided to distribute and solve it that way, I could do that as well. You will still get to the same answer. All right, let's take a look at number 2. This looks an awful lot like some of the stuff we did in Module 2. So we've got 3x plus 2 divided by 4 equals 5. So we know that right here is our equal sign. So whatever happens to one side, we have to do to the other. Since the last thing that's happening here is divide by 4, we're going to start by multiplying both sides by 4. That means these will cancel. And the thing that I'm left with on this side is 3x plus 2 equals, let's see, 5 times 4 is 20. The next thing I have to do to start getting the x alone is subtract 2, because that's the inverse of addition. So those will cancel, and I get 3x is equal to 20 minus 2, which is 18. And then when I look, I have 3x. Well, I know that that means 3 times x, so I'm going to divide both sides by 3 in order to get that to cancel. And I get that x is equal to 6. Now, if you've got a calculator with you, you should be plugging these in the calculator and making sure I'm doing all of my arithmetic stuff correctly, because sometimes I mess up too. So make sure you're checking all my work, okay? Oh, I forgot to switch colors. Oops. Sorry, guys. All right, let's take a look at number 3. Now, number 3 is different. It says 3x minus 10 equals 5x plus 4. When I look at this, there's variables on both sides here, and that's a problem. I need the variables to be together so that I can then get all the numbers on the other side. So I'm going to go ahead and draw a line at my equal sign, and I always like to move my x's to the left side just because it's what I'm used to. You don't have to, but I think it's easier to always have them on the left. So, since there's a 5x over here on the right, and I want to move it to the left side, the only way that I can do that is by subtracting 5x, because that'll get it to cancel. But that means I have to subtract 5x on this side also. Now you'll notice I purposely put it underneath the 3x, because those are my like terms. So when I do 3x minus 5x, I get negative 2x. And I didn't do anything to this minus 10, so it's just going to tag along. And then this 4 is left on this side over here. Now this problem looks exactly like this one did over here. Now it just looks normal because there's variables on one side. So next I'm going to go ahead and get rid of this 10. So I'm going to add 10 to both sides, which means these ones will cancel. And I'm left with a negative 2x equals 14. And then in order to keep getting the x by itself, I'm going to divide both sides by negative 2. And I get x is equal to negative 7. Now I know that's a little bit more involved, so if you have questions, please make sure you put a question mark or circle it or write down your question so that you can ask when you see me in class. Moving on to number 4. This looks an awful lot like some of the ones that you guys have done before, so this shouldn't be too tricky. The first thing we're going to do is get rid of this minus 7. So we're going to add 7 on both sides. And we get 2 over 5x is equal to 18. And we know that 2 over 5x, those are being multiplied, so the way to undo it is to divide by 2 over 5. So we get x is equal to, let's see, 45? Yeah, 45. All right, number 5 is a lot like number 1. We could, if we want, distribute that 3/4 inside, or because there's just a number over here, we could just divide by 3/4 first. So divide both sides by 3 over 4. The nice thing about it is that then that goes away, and on this side I just have x minus 6, and on this side, let's see, I would have 28. Again, please put it in the calculator, make sure I'm doing that right, okay? But the nice thing about it is now there's no fractions. If I would distribute the 3/4 inside there, I'd have fractions on both of these, and that makes it a lot harder. So if I can get rid of fractions, that's what I'm going to do. Now we can look at it and see the next thing we have to do to get x alone is simply just add 6 to both sides, because then those cancel, and we get that x is equal to, what would that be, 34? Yeah, 34. All right, now for number 6, let's take a look. We've got parentheses, and because we have x's on both sides, we are going to have to actually distribute here. So if I take this 4 and distribute it inside, I know that distribute means multiplication, so I'd have 4x minus 4 times 6, which is 24, equals, on this side I didn't change anything, so I just have 8x plus 16. Now on number 3, I told you I always like to have my variables on the left, which is true, but I'm going to show you guys in number 6 that you can move the variables to the left, or I'm sorry, to the right side, and it's still going to work also. So if I want my variables to be on the right side, then that means I want to get rid of this 4x. Since it's a positive 4x, I'm going to subtract it from both sides, because that gets it to cancel here. And I would just have negative 24 left on this side. 8x minus 4x is a positive 4x, and then plus 16. And now if I look, I can just keep solving like I would any other two-step equation that we did in Module 2. So I'm going to go ahead and subtract 16 from both sides. That way these cancel out, and I get 4x on this side, and what would this be, negative 40? And then I can go ahead and divide both sides by 4. So we get negative 10 is equal to x, which is the same as x equals negative 10. So if we had moved the variables to the left side instead, we would still actually get the same answer. We would still get x equals negative 10. That's the nice thing about solving equations. I know some of those were kind of review and some of them were new, so if you had questions, please, please, please make sure that you wrote them down so that we can talk about them when I see you guys in class. All right, so moving on here. we've got two students are trying to solve the equation 3x plus 6 equals 11. So we're trying to solve this equation right here. So student 1 thinks the first step should be to add 6 on both sides of the equation. Student 2 thinks that the first step should be to subtract 6 on both sides of the equation. Which student's first step would lead to a correct solution? Student 1, student 2, or both? Justify your reasoning. So what we need to do is look at this equation and think about what we would do in order to solve this. So I actually like to kind of go over on the side, 3x plus 6 equals 11, and I like to just try to solve it on my own. So if I look at this, 3x plus 6, I need to get rid of this plus 6, which means I need the inverse operation. I'm going to have to subtract 6 from both sides. That means then that student 2 is going to be correct because student 2 is the one that said subtract 6. So student 2 is correct. We know that the first step to solve this equation would be subtract 6 because subtraction is the inverse of addition. So we think that in our head all the time. All we're asking you to do right here is just write it out then. If we've got 3x plus 6, you guys know we should subtract 6 because it's the inverse of addition. That's all I'm asking you to write then. One more thing that we've got to talk about. So now we've got equivalent expressions, which we've talked about before. So two expressions are equivalent if they are equal. This means that there are the same number of variables and the same value of constants on both sides of the equal sign, which really just means we want them to be equal to each other. So if we take a look at number 8, 9, and 10, we're asked to fill in the blanks to create equivalent expressions. If we look at number 8, the left side, there's no blanks, but I can actually simplify. So I'm going to do that first, because if I look, I have a 5x plus 2x, and I know that that can combine to be a 7x plus 4 equals, I need something plus 4. Well, when I look at this, these both have plus 4, which means the constants are equal to each other. So that's good. That means the thing that's missing here is a 7x. In order to make these equivalent, these have to match exactly. So the thing that's missing there is a 7x. So again, we're trying to make it so that they are exactly the same. Now let's take a look at number 9. It gets a little bit harder. So in number 9, we need to know what can we distribute inside here so that when we look at it, we would have a 12x. So that's kind of the thing that I'm going to focus on, is on this side there's a 12x. And over here, inside the parentheses, I have a 4x. So whatever I multiply over here needs to make sure that it turns into a 12x. Now I don't know what else is going to come with it, but I know that it's going to have to be a 12x in order for these two to match. Well, in order to go from a 4x to a 12x, the number that I would have to multiply by would have to be 3. So if I take a 3, I'm going to check now, and I do 3 times 4x, that would get me a 12x. Well, now let's see what the rest of this side is equal to then. I'm going to distribute that 3 inside. So 12x, and then I have 3 times negative 2, that would give me a negative 6. That means the whole left side now becomes 12x minus 6 once I put the 3 in the blank. But then if I look, there's a blank over here also. So on that side of the equation, I have 12x already, and then it's plus some blank. Well, that's the constant piece right there. which means that has to equal that -6 because we've already got the 12x's taken care of. So this is going to have to be a -6 in the blank in order to make these equivalent to each other. And we can always just double check. I'm going to rewrite the whole thing. 3 times 4x minus 12 equals 12x. And if I have plus negative, that really becomes -6. I'm going to make sure these are equal. So I'm going to distribute that 3. 3 times 4x is 12x. 3 times -2 is -6. And on this side I have 12x minus 6. Those are equal to each other, so I know that I'm correct over here. All right, let's take a look at number 10. So in number 10, this is harder. So down here, we've got a 3x on this side, and we have an 8x on this side. In order for those to be equivalent, we're going to need to add some more over here. We need how much more? 5 more? So this blank is going to have to be a 5x, because the only way for this side to then get to be equal to an 8x would be to have 5 more x's there. So that's going to have to be a 5x. Then if I look at my constants here, I could actually combine these. So let's see, 3x and 5x gave me my 8x. And then if I do 7 and 5 and I combine those, I would get plus 12. And on this side, I already have my 8x, and it's going to be plus a blank. So we can see that that's got to be that plus 12. So in this one, we had 2 blanks. We had the 5x and we had the 12. I know that that's a little confusing. Hopefully you were able to follow along with me there. Please, please, please write down whatever questions you have so that we can talk about them in class and make sure you guys are all set. Thanks for watching.